There is a disease that plagues our species, and it affects millions of people around the world. This disease only causes mild memory loss, but it also eventually progresses to almost full-on cognitive decline, and eventually death. A major portion of the world's population has this disease, and I guarantee you that if you walked on the street right now, you probably walk by somebody who has this disease, or know somebody who does. I mean, maybe not right now, what with COVID and all. But regardless, the disease I want to talk to you about today is called Alzheimer's. And it is one of the biggest hurdles humanity has yet to overcome. Now, I won't be talking about how to cure Alzheimer's now. That's still a massive undertaking and we're still a bit away from that. Instead, what I'm going to talk about is what exactly Alzheimer's is and how we can diagnose it with using artificial intelligence. But what is Alzheimer's and what does it do to the brain? Alzheimer's is a form of dementia, which are conditions that are characterized by memory loss as well as loss of cognitive function. 60 to 80% of all dementia cases are Alzheimer's, and people over 65 have a 1 in 10 chance of getting this disease. Contrary to some people's belief though, Alzheimer's is not a normal part of human aging. Instead, it is caused by a buildup of plaques and tangles, which are made of protein, and these buildups occur in the brain tissue as well as the cells. This causes cell death as well as severing of neurons. The disease also worsens over time, with people early in the process only having minor memory loss, but people with late-stage Alzheimer's not even being able to respond to their environment properly, if even at all. On average, people live only 4 to 8 years after being diagnosed with the disease, and it is the third leading cause of death in the United States. Alzheimer's also does not have any cure, and although treatments are available, they only serve to slow down the disease, and there is no known treatment that can fully stop the disease in its tracks. And after learning all this, I think you can probably figure out how AI could be used to solve this problem. Essentially, due to cell death, gaps between the brain tissue grow larger, and the brain itself shrinks somewhat. Essentially, this happens over time, and after in late-stage Alzheimer's, the brain has shrunk somewhat, and gaps between the brain tissue are a lot bigger than they normally should be. Because of this, using an MRI scan, we can differentiate between a healthy brain and an Alzheimer's brain, as a healthy brain looks much more full and complete, while an Alzheimer's brain looks like it's wrinkled up and it's been dried out. And the same way us humans could somewhat differentiate between Alzheimer's brains and human brains, and AI could too, but probably with a much greater accuracy, and it would do a lot better at detecting early onset Alzheimer's, which is Alzheimer's that is been detected early. But how does it do this? How does the AI differentiate between an Alzheimer's brain and a healthy brain? Well, let me introduce you to convolutional neural networks, which is the artificial intelligence used to differentiate between images. Essentially, convolutional neural networks are made up of convolutional layers, which you could think of as sliding filters over the image. These filters are usually detecting things like edges and corners, but later on in the neural network, you combine these filters up, and then these new filters allow you to detect bigger objects in the image. But in this case, you would be able to detect different features. Using these features, we can predict whether the image is of one class or another. Essentially, if you wanted to differentiate between an Alzheimer's brain and a non-Alzheimer's brain, it could differentiate between those two. But in order to do that, it first needs training data. And what training data is basically data that the AI learns from, and it basically figures out how to map these features to these classes to allow it to figure out whether certain features correspond to Alzheimer's and whether other features correspond to not Alzheimer's, essentially. For example, if you wanted your AI to differentiate between a healthy brain and an Alzheimer's brain, you would need to give it the training data beforehand. And this data would be made up of a bunch of images of healthy brains and brains that have Alzheimer's. But the catch is that you put labels on each of these sets of images. So all the healthy brains would get the label healthy, and all the unhealthy brains would get the label Alzheimer's. After that, the AI will go through all the images and it will figure out what features correspond for a healthy brain and what features correspond for an Alzheimer's brain. And once it does that, as long as you have sufficient data, the AI will be able to differentiate whether a brain is an Alzheimer's brain or a healthy brain, even if you give it an entirely new image that it's never seen before. And this shows that an AI, given enough data, can classify images of MRI scans of Alzheimer's patients and figure out whether these patients have Alzheimer's or not. This could be so useful because imagine this, finding someone that has been having maybe some memory loss, and that would mean that they're having early onset Alzheimer's. And using this AI, you could detect whether that person really did have Alzheimer's or not, or if they just had some sort of mild concussion or maybe some amnesia. Theoretically, this AI would be looking at the gaps between the brain tissue to differentiate between Alzheimer's and non-Alzheimer's patients. But who knows? The AI could find another defining feature in brains that we as humans wouldn't even think to know about, or at least I wouldn't think to know about. Regardless, we now have an AI that can classify brains of Alzheimer's patients versus healthy patients. But I want you to imagine this for a second. An AI that could improve the lives of millions. An AI that could diagnose one of the worst diseases known to humanity. An AI for Alzheimer's. Thank you for watching.